On today's second chapter of the Hole Cleaning Pillar series, we're going to talk about rotation.
String rotation provides the energy required to agitate and lift cuttings from the beds on the low side of the hole into the higher velocity flow stream on the high side of the hole. This results in effective hole cleaning provided it's coupled with the minimum required low in rheology to produce the viscous coupling effect discussed later. In this comparison, we show the effect of rotating at different speeds. It's important to note that the higher rotary speeds are required for larger hole sizes, as more energy is required to account for the increased annular clearance, although it will also depend on the drill pipe size. On this test, the configuration is scaled to 8.5 hole with a 5-inch drill pipe dimensions. In the middle section, it's reduced by 8%, representing a hole size of 7, 13, and 16 inch. This reduction results not only in an increased annular velocity, but also a more effective viscous coupling due to the reduced annular clearance. In the top test section shown, the internal pipe is not rotating, and the cuttings accumulate in a clearly visible cuttings bed on the low side. With the internal pipe rotating at 50 rpm, some of the cuttings begin to be lifted from the low side of the hole due to the viscous coupling effect. Stepping up to 100 rpm, it provides more energy to increase the amount of cuttings lifted from the low side, resulting in more efficient cuttings transportation. Finally, at 150 rpm, the rotational viscous coupling effect is dispersing the cuttings more evenly throughout the cross-sectional area of the hole, with more of the cuttings reaching the high-velocity flow stream on the high side of the pipe. This results in much more efficient transportation overall. Higher rotary speeds will improve hole cleaning efficiency. However, there is a speed at which the rate of improvement in efficiency reduces, meaning that there's minimal benefit with increasing the RPM above that threshold. Plus, it can be detrimental, increasing destructive shocks and vibrations, especially in larger hole sizes. It is important to highlight that drill string rotation becomes increasingly important as the inclination increases towards 90 degrees.
Hopefully, this chapter have helped you understand the importance of rotation in the hole cleaning system to maintain and lift the cuttings on the high side of the hole where the high velocity stream is located. Stay tuned on our sites for the next chapter on the Hole Cleaning Pillar series.